This delightful hamlet of Mapledurham lies at the foot of the Chiltern Hills alongside the River Thames. It was originally built to accommodate estate workers, but it has no shop, post office, not even a pub. But you may recognise the small church that serves the local community and the watermill, as both featured in the film The Eagle Has Landed. Little has changed here over the years, but now history is about to be turned on its side, quite literally. Mapledurham House, a quintessential Tudor manor, lies at the heart of this community. The current manor, home to Jack and Lady Anne Easton, was built by Sir Michael Blount in the late 16th century, alongside the former manor house and its nearby corn and grist mill, both of which are recorded in the Domesday Book. Originally, the mill wheel was located between the mill and the small island in the Thames. The current wheel, now between the mill and the river bank, was a later addition. Today, Mapledurham's flour is used in making the bread and cakes sold in the visitors' tea room. Throughout the estate's history, owners have sought to improve efficiency and profitability, but as Mark Carlyle, the estate's land agent, explains, this has not always been successful.
There was a turbine installed next to the watermill in the 1920s for generating electricity for the main house at Mapledurham. That wasn't hugely successful. It suffered from debris collection from the river, which managed to often block the system. So it fell into disrepair.
The system lay idle for a number of years, but with growing interest in renewable energy, it was decided to reassess the feasibility of hydro-powered generation. Named after its inventor, the Greek mathematician Archimedes, a broad-bladed screw has been used for centuries to draw water from wells. Not surprisingly, with today's need for sustainable energy, engineers are adapting old concepts to new challenges.
In October 2010, Western Renewable Energy's Rupert Taylor, an experienced hydroelectric engineer, was appointed to carry out a feasibility study.
I mean, I wouldn't worry too much about that brick, because
no.
I think the river is now much better controlled than ever was later.
Gaining access for a full survey of the 16th century mill required removing the former 20th century additions. Warner Land Surveys had previously used laser measurement technology to create three-dimensional video models to aid both the submission of planning applications and to record details of every beam and piece of timber in the structure. This data would be used to ensure that the new structure would meet planning and listed building consents. The first phase of the plan to restore the watermill to its former 19th century self would then be in place.
Archimedes screw-driven systems are environmentally friendly. They have low noise, a zero-carbon footprint, and unlike wind turbines that depend upon the vagaries of wind speed and direction, the screw needs only a small difference in water level and moderate water flow to ensure almost constant power generation. And more importantly for Mapledurham, they can withstand the sort of debris from the river that had defeated previous systems.
Early spring, and it's time for the initial post-contract site meeting with the earthworks and civil engineers. Of main concern is how the work will affect visitors. Constructing the dam that will stem the mill stream and provide access to the island must not disrupt public access to the mill.
Well, you're going to, it would be inappropriate for me to say you won't know we're here. So if you assume it's somewhere between you won't know we're here and passing out, you'll be about right.
Also of concern is the stability of the island's river bank and how that might affect the location of the dam.
I think to water level and the coil roll on top. I think that in the past, I don't know how long ago, but there's a lot of chalk packages there.
Yeah, sure.
And to build that bank up.
Yeah. And the reason I'm certain you're right, and I'm certain most of that, or a lot of that on this side, is man-made. But what happens is when the start running the water on that side through the gear, it'll just take it away.
The full intention.
The warm, dry weather has been an unexpected bonus. The dam has been constructed and the site cleared. Where once there had been water, there is now mud, and the 1920s concrete work can be seen. Parts of the old turbine are retained for display in a future visitors' centre. Civil work continues steadily. The reinforced concrete that will accommodate the screw is rapidly taking shape. Will the fortune of good weather continue, or will there be delays? Perched precariously, the digger continues excavating, an almost endless task exacerbated by the soft subsoil. Similarly, the concrete work has yet to be completed. Long past damage, the building will be repaired later. The 1920s turbine drive shaft seen here will also be removed. The continuing dry spell is causing concern that water levels will be too low to allow operation when the screw is fitted in a few weeks'
I
time.
don't know whether we ought to do something about it now or not.
Well, that's discussions with the environment, isn't it?
Even now, much of the civil work needs to be completed. The construction of the walkway linking the old mill to the new turbine house has started. To preserve the appearance of the mill, it will have the same timber frame design as the original. Jack Easton and Mark Carlyle discuss progress regularly with the site manager to anticipate any future problems.
Right, do you want me to get that taken out?
Yes, yes.
But what exactly is an Archimedes screw? Well, they've been used for over 2,000 years and are still used today for irrigation. It's a deceptively simple piece of engineering. Water is scooped up into the thread and taken to the top. But it normally draws water along sloping channels, but it's equally as effective in raising water vertically through pipes, provided it rotates fast enough. But if it were to slow down or stop, why then you have an Archimedean helter-skelter, great fun for young Aristotle or Plato, but of not much practical value. On the other hand, if it were free to rotate, then the weight of children or water would cause it to rotate backwards. Now you have an Archimedes screw capable of driving a generator, and that's exactly what is being installed here at Mapledurham. The real challenge to the design engineer was to maximize the efficiency with which the flow rate from a head of water is converted into rotational energy. Now this means optimizing the length, the diameter of the rotor, its pitch, and the number of threads. Now all these were calculated by engineers at Rayhart's in Germany before the screw was fabricated.
It's 7 o'clock in the morning of the 27th of July, and the first hardware, the sluice gate and the anti-debris grids, arrive from Manpower, the Archimedes Screw specialist. The various parts are unloaded for assembly prior to installation. Using radio control, the operator positions the jib crane with great precision. The gate is slowly lifted from the transporter, swung around, lowered, and then placed upon the risers to ease its later fitting within the guide frame. Next to be unloaded is the grid that will be fitted in front of the sluice gate, to prevent debris such as driftwood or even your dead sheep entering the screw mechanism. The black-coloured high-impact strips fitted to the side of the gate will ensure smooth movement within the frame. Finally, the engineers have completed the assembly of the gate within the frame, and it is now ready for transporting to the island. The guide frame will be bolted within the new concrete work, so providing a channel for the gate to move up or down, permitting the flow of water into the screw. Inch by inch, the gate is lowered, eagerly watched and photographed. No room for a mistake now. At last, it drops into place. Nuts and bolts are tightened, and the grid is positioned in front of the gate. In order to meet planning consent, the position of the gate will be controlled by an underwater hydraulic ram. This will avoid the more usual screw system that would extend above the roofline. Today, the screw arrives, just 3 weeks later than the original estimate. After a tortuous journey down country lanes and eventually over farmland, the 10-foot wide load arrives, closely followed by the heavy lifting crane. Stabilizing jacks are extended, and it appears that everyone has their own idea of what is to be done. Railway sleepers are positioned under the jacks to improve stability. As the lifting cable is arranged around the pulleys, the delivery paperwork is completed. You just can't get away from it. The screw is contained within a trough from which it will be later removed. Jack Easton and the engineers watch as the assembly is lowered to the ground. The screw is removed, leaving just the generator within the 10-ton trough. This is the first time that a 4-entry screw has been used, and the threads are now clearly visible. Moving to the island, the crane is closely followed by the trough that will be lifted into the civil works. It's a tight fit for the lorry crossing the causeway. Lifting the trough is a particularly demanding task, since it has to be inclined to match its eventual position. It could easily swing out of alignment, but many helping hands ensure nothing is damaged and it fits correctly. The low loader returns with the screw. Weighing 15 tons, this is the heavier of the two components, and even more care has to be taken maneuvering it into position. The screw now awaits the installation of its electronic control system. Following the fitting of the turbine, the mill can now be returned to its former operational status. The old wooden wheel is dampened to reduce possible damage due to shrinkage. The repair and the new additions to the mill are completed, whilst the causeway that once provided access to the island has been removed. Once again, the mill stream flows over the old wheel. Whilst the new control system is adjusted, the old mill wheel turns for the first time this year, but it appears that there are problems with both the new and older technologies.
I think really that the whole 6 months of the wheel drying out has had an effect on it, not only outside but inside, whereby the wedges have probably shrunk just slightly, all of them. And of course, as soon as the wheel was turning again, it took a day for the moisture and everything to get back into the wheel and everything. And now it's actually reacting, that it's saying, you know, I'm not in the right places, these wedges, and something's got to give. And they're all sort of creaking and really badly cracking now. So it really needs resetting again, the actual pit wheel inside.
The control system senses water flow and, when necessary, adjusts the speed of the screw by means of the variable ratio gearbox. It also controls the output from the generator and synchronises it to the national grid to which it will supply power. This time the generator will be used as a motor so that the mechanical alignment of the screw, gearbox and generator may be checked, and all seems well. Now, just 12 months after starting work, we have the latest water power technology operating alongside that of the traditional watermill, as used down the centuries. Today, Jack and Lady Anne, together with their family, friends and members of the engineering team, gather for the switch-on ceremony. There are still a few concerns, though.
Oh, well, at the moment, the licence on the turbine, we've got to make sure that the river has got first priority on the water. So there's two conditions on the licence, which mean that we have to look at the water level going over the weir here, which is looking okay at the moment, and also the water level at the next gauging station down at Reading. At the moment, that's just below the amount of water that we need to run. The water level upstream has got to be maintained to allow for navigation. Now, however low the flow is, as long as there's some water going over the weir, the turbine could potentially run, but there's also some degree of agreement about how much water needs to go over the weir and through the fish pass for the sort of ecology of the weir pool below the weir. So that has to take priority, and at the moment we still haven't had enough rain after a fairly long dry summer.
Guests continue to enjoy their champagne and canapes, but finally the news that the Environment Agency has agreed to a short trial run is received. Jack Easton is now able to officially switch on.
I want to extend a special welcome to you all as we celebrate the installation of this Archimedes turbine. It's the culmination of many years of aspiration, planning and construction. Now we just have to go inside to be able to switch on the turbine and start it working.
Not only has Jack Easton and his colleagues overcome the engineering challenges, they have had to satisfy innumerable planning and environmental conditions imposed by historical and environmental agencies. For Jack Easton, this is the realization of a 40-year-old dream.